Good afternoon. I'm Chapalo Street, and I lead the program management team for Azure IoT Edge. Ignite is all about partners, and partners are at the heart of the strategy for Azure IoT Edge, so we thought it'd be a great day to sort of talk about some of the great improvements that we made in the project in coordination with partners like NVIDIA and Peabody. This is Chintan, and he'll come up and talk about some of the great stuff we've worked on for intelligence on smart gateways. Today, I'll start off with a quick overview of Azure IoT Edge for anyone who's unfamiliar with the product. Then we'll talk about a smart camera scenario with the Vision AI Dev Kit, and then smart gateways. And we actually have a third demo around cognitive services and speech and text recognition on the edge. 3 demos in one 20-minute talk. What can go wrong? So without further ado, the Canonical IoT pattern has been to have devices send data to the cloud, which is then processed by high-value AI or business logic to find insights. Those insights then trigger actions which are often sent back down to devices. As IoT progresses and matures, we're noticing that there's certain scenarios where that canonical pattern starts to break apart. Primarily, when a device loses its internet connection, you don't want your IoT solution to only work when you have connectivity. You want it to work seamlessly regardless of the state of the connection to the cloud. Also, some devices create so much data that you don't want to move it from the device up to the cloud to find insights about that data, primarily for video or any device that's creating data at a really high frequency. You want to find those insights locally on the device. And then finally, sometimes your solution needs real-time action on an insight found from data being created by a device. And you can go from device to cloud and back to the device in near real time in the order of like hundreds of milliseconds. But if you need a reaction in tens of milliseconds, then you really need to be running that processing locally on the device. And Azure IoT Edge allows you to bring those insights and actions and run them locally on IoT devices. Let's take a quick look at how this happens at a very high level with an example of a video analytics solution where the camera starts by sending data to the cloud, doing some data transformation through custom code, finding insight through an Azure Cognitive Service, and then triggering an action based on some more custom code from that solution. The first step to running this on the edge would be to package parts of those cloud services into OCI compatible or Docker standard containers and save those containers in a container registry. Once they're in a container registry, then you create a workload description in the cloud. And that workload description just basically says what containers you want to run on the edge device and also which edge devices you want that workload to run on. Targeting workloads is really important because you don't want your smart camera workload running on your smart oil rig. So you create your workload description and target them at a certain population of devices. When your IoT Edge device connects to the cloud, it asks IoT Hub, hey, do you have a workload that I should be running? If it does, that workload description is transferred to the IoT Edge device. The IoT Edge runtime reads that configuration, downloads the correct containers from the registry, starts them up and running, and now your IoT Edge device can operate without the internet connection. If the internet connection happens to go down while the device is trying to send some data to the cloud, the runtime's smart enough to cache the information locally and then sync it to the cloud when the connection comes back. The runtime also makes sure that those containers stay up and running because you want your devices to survive failures. And that brings me to another point of just running containers and your workloads and distributing them from the cloud isn't enough. The runtime also reports back to the cloud the status and health of your workloads so that you can take action on any problematic devices and make sure that your entire fleet of devices is operating as expected. So as a recap, Azure IoT Edge lets you create workloads which can include high-value AI or business logic, target workloads to the correct type of device, run those workloads locally in a disconnected manner, and monitor the health of those workloads from the cloud. IoT solutions are super complex. Like there's usually going to be some components on the device that knows how to speak some special protocol that these downstream devices talk. There'll be some kind of analytics engine, probably some custom business logic, and it's very specific per IoT solution. Microsoft doesn't have the capability to write all the logic necessary for every IoT solution. But what we do is we have a great partner ecosystem, and that's what Azure IoT Edge wants to allow solution developers to leverage. So when someone creates a workload definition of these different containers, we have introduced a module marketplace where a solution builder can go find skills that other people have created and that they may want to use in their solution. So it helps a solution builder accelerate their time to market, and it also allows ISVs to highlight the tech that you want to allow a partner to use. This marketplace we started in July of 2018, and it started with first-party modules only. And then in October of 2018, we expanded it to third parties, to our partner ecosystem, and added deeper tooling integration. So when you create a module, there's extensions for VS and VS Code to allow you to upload those to the module marketplace. When you're creating a solution, you can find modules in the marketplace in your dev tools. So there's really deep tooling integration with our dev tools. And then in February 2019, we started monetization of these modules because we understand that the IP that you put into these modules is often what drives your business. And so just like Azure wants to monetize things like cognitive services on the edge, we know that our partners want to monetize the IP that they put into the marketplace. So in February 2019, we allowed our first-party module, Azure Stream Analytics on the edge, to monetize, I think it's $1 per device per month. And then in 2020, we want to open up that monetization and billing pipeline to third parties so that anyone who puts a module in the marketplace can choose how they want to monetize that module running in IoT solutions. The types of hardware that you want to use in IoT solutions are almost as diverse as the actual code that you want to run in those solutions. Like, I like the example of person recognition. So if you want to do workplace safety person recognition, the ML model that you want to run on the edge is probably pretty simple, right? It just needs to recognize 2 legs, a torso, and 2 arms, like very rudimentary person recognition. And you probably aren't running it very often because you're running it in an area where hopefully people aren't anyway. And so you could probably run that on a pretty small device. However, if you want to do person recognition in an airport, you need to recognize me with a beard, without a beard, with glasses, with a hat on, and you need to be able to run that across hundreds of people a minute. And that probably requires a larger device like a server. And so Azure IoT Edge scales across a plethora of devices, from really small devices as small as a Raspberry Pi, all the way up to server-class devices, so that you can choose the hardware based on your scenario. We also allow you to choose hardware architecture. We support ARM and AMD 64, and both support Linux and Windows. The real dependency there is a Docker-compatible container runtime. Customers have told us that it's hard to find a device that works with their IoT solution, and so we've introduced the device catalog, which shows Azure IoT Edge certified devices. And this simplifies solution development so that you can find devices that work with Azure IoT Edge. And it also helps hardware makers highlight devices that work great with Azure IoT Edge. We've streamlined the certification process for people trying to get devices into the catalog. And you can find more about that at the link below there. So now let's move to the fun part of this demo, the different types of AI that you can run on the edge. And the next 3 demos try to show a plethora of different types of AI that we're running. The first one that I'll try to do is cognitive services doing text and speech recognition. So here is a freeware version of Doom, and it is running on this tablet, which is running a version of Linux. So this is your edge device right here. As we go through Doom, this is all in English. However, it'd be great to translate to Spanish. So when I click this right joystick button, we take a screenshot of what's on the screen, and then using cognitive services text recognition, we find any text in that picture, take the text out of the picture and send the text to the cloud to be translated, have the translation sent back down, and then display it on top of that screenshot. So hopefully on this screen, we should have a screenshot of that screen with the text translated into Spanish. Or let's, whoops. Let's see if that works again. So maybe some of you guys in the front row can see there is some Spanish on that screen that translated the different text options. But it's pretty cool, and it just shows text recognition running locally. As I mentioned in this demo, there's two things going on. One is recognizing the text from the screenshot. That's all happening locally on this device. Then it is being sent to the cloud to be translated. But as we work with our cloud partners to bring more and more capabilities to IoT Edge, I envision that we'll be able to do the translation locally as well very soon. So this device is our Vision AI Dev Kit, and so this was made in partnership with Qualcomm, and this shows off a smart camera. This camera has hardware inside of it that allows you to run machine learning models in real time, and it's preloaded with a model that does just object recognition. So as you can see, it's starting to recognize some people in the crowd. I think I could hold up a backpack and it would recognize that. It's going to make me a liar, so it does. But that is a Vision AI Dev Kit that is available for sale today. It's integrated with our cognitive services so that you can first deploy a pre-built object detection model to it, but then you can build your own model specific to your scenario, deploy it from the cloud, and continue to do the updating of your model in real time from the cloud. When you go to production in some certain scenarios that have video analytics on the edge, a smart camera is great if you have very isolated cameras out in remote areas that need to be an all-in-one system. However, in many factories or in production line scenarios, you'll need hundreds or maybe thousands of cameras in a relatively small area, and you don't want to pay the price for hardware on each one of those cameras. You'd rather have a really cheap camera that just streams data back to a smart gateway, and that gateway has the intelligence to be able to do the inferencing on multiple streams in real time. And so I'd like to invite our partners from NVIDIA up to talk about some of the great progress we've made to do that on devices as small as a Jetson Nano, which only costs $100. And it's super cool. So,
all right. Thank you, Chapalo. Good afternoon, everyone. My name is Chintan Shah. I'm a product manager at NVIDIA, and I work on AI products for our edge devices. Thank you. So today I'm going to cover DeepStream SDK, which is a SDK to develop AI-based applications for intelligent video analytics. So the problem that we are trying to solve is how do you apply AI on IoT device and send that data to cloud? These are a few of the industries that we can transform with IoT and cloud. The first one is Logistic Industry. The use case here is managing logistics. The application could be using camera and AI to detect packages on a conveyor belt and detect if the packages are damaged or if they're in the wrong location. And if they are, then redirect them to the right location. And send the vital metadata to the cloud to manage the warehouse. The other use case is retail. In a retail scenario, you might have an automated checkout system that uses camera. You might need cameras for loss prevention. Another area in retail that you can use is in generating heat maps. This can be used to see what the dwell time across different aisles. This can help retailers improve their placement of their products. Using edge device to do real-time inference on the edge and sending the metadata to the cloud allows us to capture both the automated checkout, loss prevention, as well as generate business insights. The last use case here is traffic. If you go look at any traffic signal, you'll see around 10 cameras. And right now, most of these cameras are pretty dumb. They're just recording things and waiting for someone to review those. With smart devices, the smart gateway devices, you can actually do AI at the edge and send the information about traffic, cars to the cloud. The challenge here is with a city, the scale of a city, you have thousands, maybe even hundreds of thousands of camera. So it's almost impossible, or your bandwidth limited, to send all that video data to the cloud. So you want to do as much of edge processing as possible and send only the useful information. So what we recognize is, even though the applications are unique, the underlying pipeline that we have to build to go from IoT sensor, the pixels, to insights, it's fairly common across industry. So generally, the way you start is you have IoT sensors, or in this case, video cameras, feeding live data, which goes to the capture side. This is where the video is captured and decoded into individual frames. From there, the frames go for pre-processing. For pre-processing, this could be color space conversion, format conversion, resolution scaling, or if the camera is a 360-degree camera, then you might need to do some dewarping. And then finally, use AI to object detection, classification, or track an object as it moves. Finally, once that's done, you generate the metadata from this and send it over to the cloud. So this is where we use the Azure IoT to take the information from our edge device to create analytics and visualization dashboards. So the applications could be unique, the industries could be unique, but the basic framework to go from your pixels to your insights are fairly common. So with that said, we have DeepStream SDK. This is a streaming analytic toolkit. It's built on open source GStreamer framework. It's a collection of plugins. At the very top, you have the application layer. This is where your DeepStream application is designed. Underneath is the SDK. What's included in the SDK is hardware accelerated plugins. So we have plugins for our decoder, which uses the NVIDIA's NVDEC accelerator. We have plugins for our encoder, which uses the NVIDIA's encoder hardware. And then for inferencing, we have the TensorRT, which is the inference accelerator, and which uses the CUDA underneath. There are a few other plugins which uses the CUDA and the multimedia APIs. In addition to that, we provide Docker containers. They are available on NGC, NVIDIA's GPU Cloud Registry, and we have recently partnered with Microsoft to bring the containers on the Azure Marketplace, and you can pull these containers directly off Azure Marketplace as well. We also provide a lot of reference applications to get you started, to get you going, and to connect to the Azure IoT, we have also included support for Azure IoT Runtime. Underneath the SDK is all the lower-level libraries that we used, that is used by DeepStream. And finally, at the bottom is all the computing platform, NVIDIA computing platform that we support. It works from tiny Jetson Nano, which I'll demo in a bit, all the way up to data center GPUs. So this is the T4s and the V100. So DeepStream, as I said, right, it's now available on Azure Marketplace, and it's absolutely free to download, to deploy. It's we don't charge anything for DeepStream, and the way you pull it is you go to the Azure Marketplace, you pull the DeepStream container, and you can deploy it on NVIDIA Jetson. You can also deploy. We have a variant for the NVIDIA Jetson, which is the ARM64. We also have another one for the x86, which is also available on Marketplace. You connect them to video cameras and connect it to the Azure IoT Edge runtime and send your insights to the IoT Hub. With that said, let me quickly go over a DeepStream demo. So this is a demo on DeepStream container running on Jetson Nano. This is a $100 device that you can grab it on online. And in the demo, I'll be showing 8 simultaneous video streams. And this is coming, doing video, reading video from file, but you can also connect your camera or read it from a live stream such as RTSP. And the output of this is a tiled display of 8 streams, as well as metadata to the Azure IoT Edge runtime. So with that said, let me switch over to the demo. All right, so what you see here is a demo of 8 simultaneous streams being processed, and it's doing basic object detection. So it's a 4-class ResNet 10 model doing object detection on cars, on people, as well as the road signs. And this application comes pre-packaged with the DeepStream SDK. So when you pull the container from Azure Marketplace, you can configure the config file to run this demo. So one thing you can do is you can actually click inside, and it will zoom in and it will show you the metadata information. So this is the unique ID of each person as he moves along, and then the bounding box across the person. Similarly, for a car, you have the unique ID of each cars that go by, and as well as the other metadata. So this is only showing object detection, but you can cascade multiple networks. So you can actually, for cars, you can have a secondary classifier that will actually detect color of the car or type of the car, and so forth and so on. And this information, it's not shown in the demo, but this information is actually being transmitted to the Azure IoT Edge. And right now, you can if you connect it to the IoT Hub, you can see all the messages that are being deployed.
Awesome. So yeah, again, seeing real-time video processing on a device this small that's as cheap as $100 is super exciting. And if you want to get your hands dirty and start playing with that, we have a session, I believe, Friday morning that will get you set up with a Jetson Nano and show you how to deploy all those the great modules from the marketplace, get a model down there, and start inferencing in real time. So thanks for your time. We'll be at our booth over in Azure IoT. We'd be happy to answer any other questions about this demo, other cognitive services running on the edge. But thank you.
Thank you.